already determined this morning here is that I'm going to buy one of those guitars and then learn how to play it. We're very pleased to have you here this morning. So let me be the first on behalf of PTC to welcome you here to our 24th consecutive PTC user event, now known as PTC Live Global 2013. We're looking forward to this opportunity to interact with you and, of course, have you interact with each other and with our partners and so forth. So thanks a lot for carving out the time and making the investment necessary to get here. We really, really appreciate that. When it comes to products and services and the relationship that these products and services create with your customers, we are in the middle of some kind of massive transformation. And then the expectations of customers around those products and how they'll use those products is changing as well. I might even argue that the crisp line between products and service is becoming blurry. How value will be created by manufacturers and then consumed by their customers is being fundamentally redefined. There definitely are forces at work here. These are large forces. It's impossible for us to constrain them. And I'd like to talk about, what they are as PTC sees them and how we've shaped our strategy and our product suite and our whole company's mission around that. Digitization is moving to a complete, accurate, high definition or high fidelity virtual representation of a product that contains all of the DNA of that product. It understands what the product is, what it does, how you'd manufacture it, how you'd service it. So this concept of this high fidelity virtual product, this is the force that PTC helped launch 25 years ago. And this force in turn helped launch PTC to be the company that brings you all here today. We really pioneered the first production-worthy 3D modeling concept, launched it in '87, and brought it to market fully in 1988. Before this concept, we all worked with drawings and sketches, and obviously 2D drawings contain a lot of information, but it's sort of in a primitive, unfinished form, if you will. And so if you look at drawings of a product, you then must in your brain compile all these bits and pieces of information and try to form this 3D image in your brain of what those parts are and how they fit together and how they might work. And quite frankly, that's pretty hard to do. It's error prone. And because it's error prone, we then had to implement physical mock-ups because there were just too many gotchas, too many bugs that had to be worked out of a product that was done in that primitive method of capturing and conveying information. So this was an expensive and time-consuming process that thankfully has given way, thanks to technologies like Creo, to 3D modeling and full 3D assemblies that not only confirm the fit of the parts, but their full behavior in the operating environment. How they move, whether they'll break, whether or not they conduct enough heat, you name it. This can all now be simulated and verified. And so this is really the engineer's benefit of digitization. But it becomes the basis for the manufacturing benefit because from this, the DNA in this virtual model, we can derive everything from CNC machine instructions all the way down to process plans to be used on the factory floor. Now, there's plenty of room for more transformation, and many companies, such as our partner Stratasys, who's here at the event, is taking this to the next level with the concept of 3D printers. In my simple view, a 3D printer is just a very tiny little factory. You give this digital product information to that factory, it starts up, does its thing, and spits out, an actual part. And these parts now are moving beyond prototyping into real, production use through various forms of additive manufacturing. There's still a ways to go, but it's moving fast. It will completely redefine the manufacturing process when it finally gets here. And in the meantime, these things are becoming so ubiquitous that you can buy them at your neighborhood office supply store now. There's room for more innovation as well, because along with the manufacturing information, we also need service information. This information is critical to installing the product, operating the product, maintaining the product. Traditionally, it was created in 2D forms, whether they're electronic or paper 2D, text and graphics and simple pictures. That is a very low bandwidth way to communicate information into the human brain. So PTC has been innovating and pioneering the introduction of 3D and graphics, building off that same virtual model. And this video here will give you a sense of just how much more rapidly information can be conveyed. This doesn't need to be translated. You don't need to read and study it and think about what it meant. It's completely obvious. It's extremely fast way to communicate information. So I would argue that the demand for this right now is extremely large, and it offers a breakthrough in service efficiency that has an incredible value proposition attached to it. A great example to talk about today is one of our customers, College Park. So College Park makes prosthetic feet. And as you might guess, because human feet are all different, well, their prosthetic replacements have to be unique and customized for the user as well. And that's not just a cosmetic thing, it's an engineering thing. So College Park uses Creo to simulate, to design, assemble, and then simulate each foot so that they can very rapidly bring unique feet to market to meet an individual user's need, who obviously wants that foot as soon as possible. So this type of approach saves months and months in the process of bringing such a product to market. So that's the story on digitization that I covered last year, but I would say it's only one of the forces, really, that we should talk about. Now, digitization, or let me say digital technology in general, coupled with the internet, coupled with, for example, the commoditization of air travel, has completely unleashed this next force we would refer to as globalization. And globalization is completely changing the way we think about the world that we live in and that we build products for. So it's technology that's tearing down these boundaries, these geographical boundaries and these economic boundaries, and allowing information to flow freely around the world almost instantaneously. Now, like anything else, there's good parts and bad parts of globalization, but I would argue it realistically is not much of an option anymore. For example, there's a recent McKinsey study that said by the year 2025, 70% of the demand for manufactured goods will come from countries that we classify today as developing countries. Well, I don't know about you, but I like to live in the world of the 100%, not the world of the 30%. It's pretty difficult to make a living in the world of the 30%. So we used to think, perhaps growing up, that business could be local, or perhaps it could be national. But today, we know that that's not so viable. Viable businesses need to think globally, because if you don't go after that 70%, somebody else will, and when they fill that vacuum, you'll then have a hard time competing even in the 30%. Globalization is here to stay. It's affected innovation. You know, this idea of some really intelligent person, some inventor that has a great idea, a Ben Franklin or a John Browning, you know, that invents so prolific, range of new products. That's giving way to a different kind of process, which is sort of global, collaborative information sharing and innovation. And the best companies are doing it in what we would characterize as a design anywhere, build anywhere, and sometimes sell and service everywhere type of strategy. So a great example of one of our customers who's doing this is Egco. Egco makes agriculture equipment. They sell it in 140 countries around the world through 3,100 dealers. They have a very distributed product development team. Part of it is in France, parts in India, parts in Brazil, parts in the US. They all need to work together. And they knew that these people need to work together effectively and efficiently if they want to increase quality and decrease time to market by implementing strategies like part reuse and better change and configuration management processes. So Egco did what so many of our design anywhere, build anywhere customers have done, which is deployed a single source of product truth to help the engineers collaborate and work together efficiently, but also make sure that the right information was being communicated to any factory or to any service people. So Egco is a great example of a customer who uses virtually all of PTC's solution suite right now to implement this design anywhere, build anywhere, sell and service everywhere model. One of the things that's interesting about globalization is as you begin to implement globalization, you have access to all these incredible new market opportunities and so forth, but pretty soon you realize that in each region, there's a new rule book. And so whereas there's momentum from globalization, there's a strong headwind coming from regulation. And there are many different kinds of regulations. They're coming from governments, they're coming from non-government agencies, they're coming from industry bodies. We used to think of business being done between two companies or two people. A contract, that contract turns loose the free flow of goods, constrained really only by market requirements. But that world doesn't really exist anymore. Today, there are many, many bodies who will impose regulations. In fact, there's a study done by the Manufacturing Alliance for Productivity and Innovation that claims that in the last 30 years, manufacturing companies have been subjected to 2,000 new regulations. Regulations related to protecting the environment, protecting the health of the workers and the customers, safety, trade, you name it, economic protection, many, many different examples. Some we could talk about, for example, would be like REACH or ROSE, originated first in the European Union and then spreading. Many, many different standard or industry bodies. And then the latest classic example is the conflict minerals regulations that come from the US government, from the Securities and Exchange Commission. A good example of a customer who's confronted this head on is Motorola. And I'm talking about Motorola Mobility, which is that part of Google that makes cell phones and mobile devices. Motorola Mobility has 50,000 products that contain 300,000 supplier parts coming from more than 4,000 individual suppliers. And because Motorola and Google both have a brand that is in part built up around principles of corporate social responsibility, they were quick using our Windchill product analytics capability to implement a solution to help them audit all of the influx of parts that they get from their suppliers to determine which of those parts might contain these conflict minerals such that they could design either those suppliers or those parts out of their products going forward. So Motorola is doing not only the right thing for their shareholders, but they're doing the right thing for the environment as well. The second force one runs into when one globalizes is the force of personalization. And that is that people in different regions simply want different things. Maybe not completely different things, but at a minimum, somewhat different things. So it's no longer really viable to think that you're going to take a single product and ship it everywhere in the world. What you're going to find out is there's both regional and personal preferences that have to be accommodated in order to have a winning strategy. And the idea of a winning strategy is a strategy that we and our customers characterize as diversity with scale. So accommodate the customer's desire for difference, that's the diversity part, without giving up the economies of scale. So the strategy of balanced diversity with scale is critical. And there's a couple of phases that companies are going through. The first phase is really to accommodate regional variability. And the second phase is to accommodate personal variability, which is much finer grained. So on the regional variability part, it can be as simple as in the UK, people drive cars on the opposite side of the road, so the steering wheel has to move to the other side. It might be that they use different fuel, or their power supplies have different voltage. Or it could be that there are different environmental operating characteristics. They might be dry and sandy, or wet and cold, or what have you. Or there could be different rules about the kind of product. For example, the car you can sell in Europe, you can't actually sell in California here because it's not allowed. So there's a lot of reasons why regionally products end up being different. And this gets companies started down this path toward mass customization. Now, in order to retain the economies of scale, a lot of our customers start thinking about what's a smart way to do this. And they land on the idea of a platform strategy with variants and options that are configurable. Meaning there's really a single product, but we can put it together so many different ways that there's an explosion, a mathematical explosion of possibilities. And within that range of possibilities, we can meet most of the needs of most of our customers. A good example of regional variability that's sort of unanticipated is this concept of reverse innovation. So reverse innovation is what happens when sometimes you start thinking about, for example, how would I have to change my product to make it work in a developing country? So for example, the ultrasound machine on the left, the sonogram, is designed to be portable and battery operated. And then once people realized that you could actually package this technology into such a small package, they said, you know, that's actually a better package than we have back in the US. Let's import this thing back in, for example, to the developed countries, but we might tweak it a little bit, and we end up with something like is shown on the right, which is a still much smaller footprint than the machine it originally replaced. So there's some really interesting innovation that creeps out of attempts to think about different customers imposing slightly different requirements on your products. A great customer who solved this problem of diversity with scale is Volvo Truck. Now, if you make heavy trucks, you understand that each and every truck ends up being subjected or becomes dependent upon a number of factors. What's the truck going to be used for? Is it a sleeping truck or not a sleeping truck? What will we haul? Will we drive it in Europe or will we drive it in the US? What fuel will we burn in it? And so forth. And it really starts to get even beyond regional diversity into driver preference diversity. Volvo has mastered a scheme that allows them to produce hundreds of thousands of trucks each year in more than 100,000 different configurations. So it's only rare that several trucks come off the assembly line in the exact same configuration. But the key thing for Volvo is how to do this effectively and efficiently. They know it's important because there's a study from Frost and Sullivan that says by 2018, more than 50% of the new trucks coming to market will have this type of platform configurable capability. So they understand how critical it is. You can only go so far with mechanical variability. You can't really get to mass customization in markets of one because those parts are expensive to produce. And if you end up with lot sizes of one part, you end up with manufacturing costs that are a bit hard to amortize and need to be assigned to that one single customer. And then you end up with price points that don't work that well. But it turns out that software starts to break that rule because software has no manufacturing cost as we previously understood it. So now people are understanding that I can get so far with mechanical variability, but then I can switch to software variability and I can get a lot farther yet. And then we, as consumers, if you think, for example, about smartphones, the last step of the manufacturing process happens in the consumer's home. When they bring that phone home and they connect it to the internet and they start loading it up with the software that reflects their personal preferences. So I think smartphones are pretty limited in mechanical diversity. If I remember correctly, last time I bought an iPhone, it came in 2 colors and 2 memory configurations. That was it. But if we all pulled out our smartphones and compared them one to each other, I don't think we'd find 2 of them that are the same. And that's because we've all customized that last mile in software ourselves. Because our vision of what a phone does and how we're going to use it is unique. Each one of us has a slightly different perspective. So this provides the best example of taking diversity from regional to ultimately personal levels. And it's not really limited to smartphones. I mean, this is starting to show up in automobiles and ultimately will show up lots of different places. What we find next is that software has more uses than just configuration. It completely changes the way we interact with a product. It changes what that product can do. And it changes the way that product can collect information about its usage and its diagnostics and its service needs and so forth. And so that brings us to the next force, which is really software eating. So many of you might have read this famous, I believe it was a New York Times article originally from Mark Andreessen, the original founder of Netscape and now a venture capitalist. He wrote this article that said software is eating the world, and he basically said, you may not know it, but you're a software company. And you better figure out how to be a good software company, because as the value continues to shift from hardware to software, your ability to differentiate, sustain your advantage, is going to become embedded in software. And this software has disrupted so many markets, it is poised to disrupt more. Essentially what we're talking about is a shift from purely mechanical devices and systems to more sophisticated systems that integrate hardware and software together, that provide a rich user interface, a man-machine interface, provide the ability to collect information, and then have parts that can be changed well after the fact, upgraded years later, without having to remanufacture the product. So there are some products out there still that don't contain software. They're starting to become the exception rather than the rule. We own products at home that don't contain software, or so far as we know, don't contain software. But more and more, software is used to redefine the product. You know, I'm a pilot, and I can tell you that if you got an airplane made prior to the year 2000, it didn't look anything like this. But today, this glass cockpit is one of the single biggest differentiators when comparing one aircraft to another. It completely changes the way the pilot and the airplane interact with each other. It's also changing, you know, the way that the service technician and the aircraft interoperate with each other. So it's a tremendous force, and it's not just showing up in airplanes, it's showing up in refrigerators and appliances and everything else, and giving us much richer control of these products. Instead of a mechanical dial, there's lots of settings and parameters. I think my coffee maker at home has something like 50 different setting and parameters. How hot do I want the coffee? How coarse do I want the grind? How long should it wait to shut off after I don't interact with it for a while, and so forth. All these settings that give me just this rich ability to make that coffee maker work exactly as I want it to. One of the great examples of software changing the world is a customer of ours, Continental. So Continental is a tier 1 automotive supplier based in Germany. And if you go back a ways in the history of Continental and the various companies they acquired, not that far back, everything was mechanical. But today, as a tier 1 system supplier, Continental employs far more software engineers than they do mechanical engineers, because that's where the innovation is happening. For example, if you look at these windshield wipers, you know, what makes windshield wipers innovative? Well, automated controls. So that you don't have to sit there and turn them on, turn them off when there's a little bit of mist or whatever. Now they sense water, and when they sense enough water, they wipe. When they sense a lot of water, they wipe really fast with greater frequency and so forth. And then the latest versions of the smart systems are smarter yet. If you park your car and you leave the windows open while you run into the supermarket and it starts to rain, the car says, uh-oh, I better put the windows up, because I know it's raining and I know this person wouldn't want rain inside their car. So it's a great example of fairly dumb products becoming extremely smart, you know, in a relatively short period of time. So once you have these smart products, which essentially have CPUs and software, then somebody says, well, why don't we just give them an IP address and connect them to the internet? Now, I'm not talking about the traditional internet as we think of it, you know, with servers and laptops and so forth connected. I'm talking about things on the internet that aren't really computers. Well, I guess they are, but you don't think of them that way. You think of them as your coffee maker or your refrigerator or your automobile. But these things now are really connected to the internet, and they bring on this concept of the Internet of Things. So now we can actually see these products. Years later, after we produce them, we can interrogate them, we can upgrade them, we can gather usage information and statistics, and create this enormous pool of data from all of our products that are essentially created or connected through the Internet of Things in some kind of a digital umbilical cord. This concept of connectivity really gives us this remote control of products, this remote visibility, so that we can understand what's happening in real time and interact even with fleets of products that are deployed out there. Now, as before, there are products that aren't on the Internet of Things and never will be on the Internet of Things. And there are maybe even some products that have software but aren't connected. But this is really becoming more of a rarity than it is the rule, because the rule is toward products that are smart and connected. For example, I love this new trend referred to as the quantified self, where people say, well, why don't you collect information about me, about my exercise and physical habits, so that I can connect that information and compare it to a database that compares it to my goals for physical activity, compares it to peers, compares it to challenges I have, you name it, so that we can collect information even from people. And of course, it's not just the quantified self, it's all kinds of remote control products. Products that allow doctors to participate in surgery without ever touching the patient. And though in this case they're in the room, they could as well be 1,000 miles away, because they're looking at a computer screen controlling a remote device. So there's great examples of this all over the place, but one I like to talk about is Schneider Electric. So Schneider Electric is a large French company that manufactures equipment for electrical power distribution and then for industrial control and automation. And knowing that 40% of the world's electricity is consumed in buildings, they've created the concept of high-performance connected buildings, where they're monitoring lighting, heating and cooling, information technology and data centers, and security through a single integrated dashboard. And by managing this integrated approach, they can reduce the energy consumption of a building like this by 30%, which does dramatic things to the operating costs and to the overall business performance of the company who owns that building. So it's an incredible example of smart connected products. If you take this idea so far of global products, highly configurable, smart and connected, that completely transforms the way the products can be serviced. We've all been thinking about servicing products we can't see, but what if we can see them and talk to them and so forth? So as that opening video suggested, this concept of servitization is really one of the biggest transformations that's happening overall. Now, servitization is an academic term. PTC didn't create it, but we kind of like it. And it really just refers to the fact that products and related services being bundled together into a new integrated offering that represents a new kind of value to the customer. And that this value increasingly can be consumed as a service. So it's on demand. It might be utility priced, use it for a while, stop using it, stop paying for it. What we're fundamentally talking about here, though, is incrementally shifting the ownership responsibility from the customer back to the manufacturer. We're saying, I tell you what, you keep the product, I just want the benefit. We all, of course, live in a consumer society. We like buying things, we like owning things. Some of these things are pretty fun. They're great, but ultimately this is changing. The car you drive or the heating and cooling system that sits on top of this building, was probably purchased. But more and more, people are thinking about different models because they don't like, it's fun to own the thing, but it's not so much fun to carry the risk that it breaks, the cost of ownership, and the responsibility of maintaining this thing to keep it working. It'd be a lot better to just have the benefit of it. And 20 years ago, Rolls-Royce realized that jet engines are pretty complex and expensive and risky to own, when all you really want is airplanes that fly. So why don't I sell you power by the hour? And you don't actually have to take ownership of the engine. I'll just hang it on your airplane and turn the meter on whenever you're flying and charge you according to how much it's been used, but I'll maintain the spare parts, maintain the technicians, all that type of stuff, because I can do it across airlines so much more efficiently than you can do it yourself. This is following now into other places. Music, you don't really buy anymore, not the way you used to. Entertainment, software is changing, lots of different industries. Why can't it go everywhere? Well, I think it probably will. We're seeing this now in transportation. Many big cities, including Boston, where I live, have this concept of, this is Hubway, bicycles. Bicycles that are specifically designed, engineered, to be used as a service and not sold to the end customer. And it's a huge convenience to be able to take a bicycle from point A to point B, a cab from point B to point C, and then a bicycle from point C back to point A. It's a huge convenience to not actually own that bicycle. And of course, this is being applied to zip cars and more business models than you can really even imagine. So a good example of a customer who's rethinking product as a service is Ingersoll Rand. They have products and services that create comfortable and safe, efficient environments for people to live and work in. And one of their business units, Train, has used this concept of smart connected products to create new services. They collect data and then sell that data and the various interpretations of it back to the customers to help the customers make better decisions about the buildings that they own as well. So it's a very interesting example. Now, if you think about any one of these forces, by itself, it's a big deal. Any one of these forces could help you gain an advantage on a competitor or put you at a big disadvantage if they beat you to it. But I would position with you that the sum of all of them is completely transformational. This is a life or death moment for companies to either get ahead of these things, realize the world of the future is smart, connected, global, configurable products, and try to win in that world, or perhaps get run over by new people who disrupt your market, your business, by getting to this concept before you. So this is a great opportunity for PTC. This is what our strategy is all about. This is why we have CAD and PLM and ALM and SCM and SLM technologies that you're going to hear about, because that's the building blocks to help people implement smart connected products delivered, with or as services. I think it's also a great opportunity for you, because your companies are going through transformations, and your ability to guide your companies in terms of their own strategy for using technology to harness these forces for constructive use, is not only good for your career, it's very good for your company. So it just might be that the fortune teller knows what she's talking about after all. So thank you very much, and have a good time here in Anaheim. I appreciate it.